So we have moved up to quadratic equations, and as you know, quadratic equations are any equations that have a squared, right? So linear equations have a plane x, quadratic equations have a squared. You have been solving quadratic equations by factoring for a long time, so this should feel pretty easy to you. The first step I call the zero step because it's about setting the equation equal to zero. Then we factor, and then after we factor, we use this property of zero products, which says if two things multiply to zero, one of them has to be zero. So we set each factor equal to zero and then solve from there. So for step number 2, we're using this property of zero products, which says if A times B equals 0, then either A is 0 or B is 0. So here's one that's done for you, right? X squared plus 5x plus 6. Notice that it's already equal to 0. It's factored or broken down into the two binomials, which are then given into two mini equations, right? If those two multiply together to give you 0, either one has to be 0 or the other. And then here we solve this by subtracting 3 from both sides, solve that by subtracting 2 from both sides. At this point in your math career, you've done these a lot, so this should not feel challenging, and just a nice review, right? Two things that multiply together to give you z, z and z, right? Two things that multiply together to give you 27, but they have to add to negative 12, so z minus 9 and z minus 3 equals 0. We still want to write our mini equations. It's tempting to go right to the answer, but I do want to see this step, z minus 3 equals 0, z minus 9 equals 0. It's okay if you just solve that in your head, so z equals 3 or z equals 9. Easy speasy. Next one here, and you should be able to do this pretty quickly, is x plus 8, x plus 5. It's tedious, but I still want to see the two equations, and then solving those two equations, getting negative 8 and negative 5. When the signs start to change, we got to think a little bit more. Now we need two numbers that multiply to a negative 44 and add to a negative 7. So x minus 11 equals 0 and x plus 4 equals 0. So x equals 11 and x equals negative 4. This one can be tricky for people. It's not a trinomial. This one is a common factor question. So the common factor here is n, and we're left with n minus 5. So once we have that, then we can, oops, doesn't like it someday for some reason. So equals 0. Then we're going to set each factor equal to 0. Let's try it this way. There we go. So n equals 0 or n minus 5 equals 0. So n equals 5. Perfect. This is the first one where we see that it's not equal to 0 to start off with, so we're going to have to add 36 to both sides. X squared minus 12x plus 36 equals 0. This is a perfect squared trinomial, and when we factor it, we get two of the same answers. And people always say, do I have to write them twice? Yes. That is called a double root, and that's going to have significance in the graph, so we do write it twice. Here, leading coefficient trinomial would be 3s and s, and then here minus 5 and plus 2 will give me an inners and outers that add up to negative 13. Here where we solve this, and here where we solve this, I know my s's and 5's kind of look alike, that's going to be 5, where this one's going to be negative 2/3. At the bottom, we're going to talk about some trinomials that don't have an x term. When you don't have an x term, you can do a little bit different solving method. You can take the square root of both sides. But when you do that, you have to take plus or minus. The reason is if I were to solve this question by factoring, there's still two answers. X plus 3, x minus 3, x is negative 3, x is positive 3. So when you take that plus or minus on the square root, you're accounting for both roots. Here, if I solve 7x squared equals 35, x squared is 5, it's not a perfect square, but I can still solve it by taking plus or minus the square root of 5. This one's a little more involved. Here, if I add 8 to both sides, I get 10. Square root, plus or minus square root of 10. I'm going to add 4 to both sides, put that 4 first, plus or minus root 10, and then divide both sides by 5. So my final answer, 4 plus or minus root 10 over 5. By the way, number 8 and number 9 could not have been solved by factoring, right, with those square root answers, but they can be solved by this method. So here is solving quadratics by factoring.